So when you guys come to your related rate problems, I highly recommend that you always draw an illustration. Now some of you guys have really good illustrations going on in your head, and you might not need to draw it, but because there's so many other things to think about, I think drawing an illustration really helps. The other thing is identifying variables. Since these are related rate problems, you should have like a d something, like dv over dt, something over dt, because these are rate problems. So we should have some rate variables. And then the last thing is your relating equation. Now this is the hardest part, I think, for most students, is finding the relating equation, because they don't give you the equations every single time. You have to figure out, like, the problems expect you to know how to find the volume of a cone, or find the volume of a box, or like what equals distance, you know, stuff like that. So to draw our illustration for this one, it says the water pours into a fish tank at a rate of this. How fast will the water level be rising? Okay, so you can draw yourself a tank. Whoops. Okay, what a great tank. Oh, that's great.
Beautiful.
Beautiful tank. And then you can even draw some water if you wanted some water. Should we draw a spout? No, I don't think I want to draw a spout, just for the sake of time. It's okay. Don't worry about it. Okay, so let's label it. This is it's 2 by 3 on the bottom. It says it's a rectangular dimensions. Okay, and these are our meters. So that's our illustration. What about our variables? Okay, it did give us a rate. So if you wrote the rate down, how would you label that rate? It says 0.3 meters cubed per minute. What would that rate be? Like, how would you label that one? dV over dt? Is that how the volume is changing?
Where is the 6 centimeters, Charlie?
It's true. You're totally jumping ahead of me, but let's see if everybody can label everything right. So that's the rate that it gives you. But what is it that we want? It says how fast is the water level rising? So that's a rate right there. How would you label that one? Sure, dH over dt. Now since we're busting out an h here, let's label what h is. H is what? Height of water. This is not the height of the tank itself. This is the height of the water. So h would be from here to here. So this is h, because the height of the water. So dH over dt is the rate, or change in height, of water. I like change better. Change in height of water. Now the last part. Can you, oh wait, we have a dV over dt. We forgot to label V. What does V represent?
Volume.
Volume of what?
Of the tank.
No, not tank.
Water.
Of water. So we got all our variables laid out. Now what we need to do, before we can get to these guys right here, our rates, we have to have a relating equation. So look at V and H. Can you come up with an equation or a formula that will relate the V and the H? Yes. Volume equals base times height times, well, it's supposed to be base, width, height. Oh, it doesn't matter. Like, this would be our base, this is our width.
With length, height.
Yeah, width, length, height. Oh yeah, that's the one that I think is used a lot. But we know what base and width are. And our base and width, are they changing? Like, can those change? In this situation, in this context, they cannot change. Sometimes you guys will come to a problem where they can change. And if they do change, then you don't want to sub in what they are right away. You want to first take your derivative so you can have the other rates in there. I don't know, it depends on the problem. But since the B and the W will not change, you would just write those in. So you have 3 times 2 times the H, and so V equals 6 times h. So now we have our equation that relates the two variables. That's cool. Now we would take the derivatives so we can have our rate variables in here. Those are these guys. So if I take the derivative of v, that would be, you drop the 1, and then you subtract 1, so it'd be v to the 0 power, which is just 1. So it'd be 1 times dv over dt. Think of like when you derive implicitly. The next one's going to be 6 dh over dt. I'm going to skip all the extra stuff because you know that if you just took the derivative of h, it would be 1. And so now if I were to solve for dh over dt, since that's what the problem wants, it wants what dh over dt is, we would multiply both sides by 1 over 6. And so now you have 1 over 6 dv over dt. And do we know what dv over dt is? Yeah, so we can plug that in. Now 0.3, since I already have a fraction right here, 0.3 is the same as 3 over 10. You guys okay with that? 3/10. So that equals dh over dt. And then we could cross out that 3, make it a 1. That 6 becomes a 2. So now we have 1 over 20. So dh over dt is 1 over 20. Now what's my units for this one?
Meters per minute.
Yes, it's meters per minute. Why is it not meters cubed like this one?
Height.
Yeah, because this is the height. Remember what dh is? H is the height. That's not going to be measured in cubic meters. It's just going to be measured in meters. And so those are your units for that one.